In this video, we will learn what ionic bonding is. You know very well that elements tend to interact with other elements in order to attain stability. Stable elements are those elements that have the same configuration as the noble gases. Noble gases are stable elements, that's why it actually did not participate in any chemical bonding. In this video, we will know what ionic bonding is. Let us define first what is ionic bonding. Ionic bonding is a type of bond which involves transfer of electrons from one atom to another in order to attain stability. Ionic bonding happens between metals and non-metals. So let us have example in order for us to understand what ionic bonding is. Let's say for example, since it is bonding between metal and non-metal, let's have first the metal followed by the non-metal. So let's go to our periodic table to have examples. So you know very well that the metals in the periodic table are these part here. The reds, the blue, the orange here, and then some blue here, and then the rest here are the non-metals. So let's say for example, we want to take sodium and chlorine. Sodium has an atomic number of 11, while chlorine has atomic number of 17. Sodium is 11, while chlorine is 17. In order for you to show that there is ionic bonding in these two, you need to use first the Lewis dot notation to signify the valence electron found in each atom. So for sodium, since it belongs to the group 1 element, the Lewis dot notation would be like this. And for chlorine, since it belongs to the group 7 elements, the Lewis dot notation would be like this. Remember that there is a rule to be followed during chemical bonding. We have the octet rule, meaning to say if an element attained an 8 valence electrons in its highest energy level, that means the electron is already stable. In our case, sodium has 1, it needs 7 more electrons for it to attain octet rule. The same way with chlorine. Chlorine has 7 valence electron. It only needs 1 valence electron in order for it to be stable. Since I've mentioned that ionic bonding is the transfer of electrons from one atom to another, in this type of bonding, there will be transfer of electrons from sodium to chlorine. Usually, the metals tend to lose their electrons as explained by their properties in the periodic trends which we have discussed last time. In order to show that there is transfer of electron, the use of arrows can explain it. So like this. The use of arrows signifies transfer of electrons. Now rewriting the Lewis dot notation, we can write it like this. Since sodium lose 1 electron, it is now more positive than negative, since electron is negatively charged. So we will write it here as an ion. We have here positive 1 because it lose 1 electron, meaning to say it is now charged as positive 1 because it has an exceeding 1 proton, while chlorines attaining an octet rule will be like this. Chlorine, and it's now have more electrons, so it's negative 1. So that is now the ionic bonding between sodium and chlorine. Let's try another example. Now let's try the element from the group 2. Let's try magnesium and sulfur. Magnesium is 12, sulfur is 16. Okay. Magnesium and then sulfur. Magnesium is a group 2 element, while sulfur is 1, 2, 3, 4, 5, 6. Group 6 element. Group 6. Okay, so writing its Lewis dot notation would be like this. Mg and then 1 and then 2. Sulfur is from the group 6, so 1, 2, 3, 4, 5, 6. Sulfur needs 2 more electrons in order for it to attain a noble gas configuration of 8 valence electron, while magnesium has extra electrons at its outermost energy level. So what will happen is magnesium will transfer its 2 valence electrons to sulfur in order for it both to attain a noble gas configuration. So rewriting it, we will be forming ions. So Mg will be positive 2, while sulfur will be negative 2. So that's the chemical bond between magnesium and sulfur. Let's have another example. Now let's try to have calcium and oxygen. Calcium is group 2, while oxygen is 2, 3, 4, 5, 6, group 6. Group 2 and group 6. Calcium group 2 and oxygen group 6. So if you are going to write the Lewis dot notation for calcium, since it's group 2, it has 2 valence electron, while oxygen is from group 6, it means it has 6 valence electrons. Oxygen needs 2 more electrons in order for it to attain a noble gas configuration. So what will happen is that calcium will transfer its electrons to oxygen, giving way to the formation of ions of calcium, positive 2, and oxygen, negative 2, forming now this compound. Now another question will be, did calcium really attain the octet rule? Did calcium really attain the octet rule? Yes or no? The answer is yes. Now in order for us to understand it very well, we are going to go back to its electronic configuration. So let us write first the electronic configuration of calcium. Calcium is Ca and its atomic number is 20. If you're going to write the electronic configuration, that would be 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2. Now let me just recheck if we have write the correct electronic configuration for calcium. 1s2 is 2p6, 3s2, 3p6, 4s2. Okay, so that is correct. Okay, so if you're going to draw the atomic structure for calcium, we have here calcium, say that this is the nucleus of the atom calcium. In the first energy level, we only have 2 electrons. In the second energy level, we have 8 electrons. In the third energy levels, we have 8 electrons. And in the fourth energy level, we have 2 electrons. During the chemical bonding, these 2 electrons were given off to the element oxygen, and so 2 is now not existing in the structure. What was left with calcium is the 8 electrons in the third energy level, which means it has followed the octet rule. The same also happened with the other elements that we have in the first and second examples.